Hi everyone, welcome back. This module will demonstrate how to draw a bar chart with R. Without further ado, let's move on to the introduction of bar chart. A bar chart is a visualization tool that presents categorical data with rectangular bars. The heights or lengths of the bars are proportional to the values that they represent. Bar charts may be plotted vertically or horizontally. Let's start with the vertical one first. Before creating a vertical bar chart, we need to read the dataset into RStudio. Here, we also use the same sales data as we did in the previous video. Use the read.csv function and we can import the dataset. The sales dataset consists of 4 product types, including bread, cake, candy, and cookie. We can use the bar chart to analyze the sales revenue and examine the popularity of each product. To draw a bar chart, we need the ggplot function plus the geombar function. The default direction of geombar is vertical, so the computer automatically draws a vertical bar chart for you if you did not specify its direction. In this example, we are counting how many times each product was bought. X-axis shows the 4 products and Y-axis represents the number of times. To do so, we need to specify X-axis as product by using the ACE function inside ggplot. We don't need to specify Y-axis because geombar counts the frequency by default. After running the command, this is the vertical bar chart that you will get. To modify the color of each bar, you can add fill equals to product inside the ACE function of ggplot. With this command, you are telling R to give each bar a color by default. After running this command, you will also get a legend on the right, showing the colors for each product type. R allows you to customize the chart according to your preference. We can change the width, color, and opacity of the bars with width, fill, and alpha functions. We can also change the frame of bars by using color and size functions to change the color and thickness of the frame. Here, we set the bar width equals to 0.5. Change all the bars into blue with opacity of 0.7. To make it clear, the opacity function changes the transparency of the color. In addition, the bars have flex frame of size equals to 0.5. This is how it looks like. The bar charts we just created has y-axis of count. Now let's change y-axis to represent sales of each product type. To do so, we need to create a data frame first. We use the aggregate function to do the work. There are many ways to apply the aggregate function. Basically, it can split the data into subsets, compute summary statistics for each subset, and returns the result in the data frame. In our case, we need to put formula, data, and function inside the brackets. Let's take a look at each component one by one. The formula is written with the tilde operator. Suppose that the formula is y tilde x. This means that the y variable's numeric data will be split into groups according to the grouping of x variables. As we are examining the sales of each product type, we can write a formula of sales tilde product. This formula means that the value of sales will be split into groups based on the grouping of product. Next, the data is where the variables and formula should be taken. In the example, data comes from the file data, so we need to put the file name in the brackets. Last, function in the brackets helps you to compute the summary statistics which can be applied to all data subsets. Since we want to add up all the sales of each product type, we need to use the sum function here. This is how the aggregate command looks like in our example. Now we have this code in R. Let's run this command, and we can get the new data frame called data2. It specifies the total sales for each product type. Since we created this new data frame, and the following ggplot function, we need to change the data specification into data2. As we want each bar to show the sales of product, x-axis should be set equals to product, and y-axis to be equals to sales. To give the bars color, we can set fill equals to product. Be careful that we are using geom column instead of geom bar in this demonstration. The geom column function allows you to specify the y value of each bar. It can make the bars represent the values of the dataset. On the other hand, the geom bar function counts the number of cases at each x position, which is demonstrated earlier. Since we want the heights of the bars to represent sales value, we need to use geom column here. Run the whole command and you can get this bar chart. Similar to geom bar, you can also change the width of bars with the geom column function. Inside the brackets, set a value to width and you can change the size of the bars. Suppose that you want to show the value of each bar in the chart, making it clear for viewers. You can add the geom text function to the codes. Inside the brackets of geom text, add the ACE function. Then set label equals to sales in the ACE function, and you will get this bar chart with labels. Now, the labels are overlapped with the bars. To move the labels upward, set vjust equals to a negative value. In this example, let's set vjust equals to negative 0.5. Then the labels will move upward vertically. If you want to turn the bars into horizontal ones, simply add the chord flip function to the codes and you can get the result. Since the horizontal bar chart is flipped from the vertical one, it has the same settings of color, labels, and sequence. Before exporting the bar chart, remember to add title, rename X and Y axis, as well as add captions to make it more professional. This is done with the same command we used before. Add the labs function to the code and you will get this chart. We're done with all the demonstrations in this video. To conclude, art allows you to plot beautiful charts with customized designs. This is a useful tool for you to present data analysis results. So please try them out and be familiar with the codes. Next video will focus on pie chart. Please move on to the next module.